Tier 1 Math K-3 Curriculum Units and Guided Instruction Part 1. The content in this session is geared toward K-3 teachers, but it truly could apply to all teachers, and it's focused on Part 1 of Guided Instruction. There is a Part 2 available that provides a lot more detail and specific strategies. But here, we have a quick overview of Guided Instruction. So specifically, our goals are to explore what guided instruction could look like and how it builds on the opening routine and formative task, so that we all have a common understanding and vision for those first three components of the math block. And we want to explore how to use our inclusive curriculum resources to plan for guided instruction, so that our planning process is easier and more impactful. We know you have a lot to plan, so we want to think about how to really streamline that process. Let's start by thinking about what guided instruction could look like and how it builds on the opening routine and formative task. Let's start by returning to our definition for math instruction. This comes from our math instructional guide, where we write, "The math classroom should be a space that centers children and fosters curiosity and joy. We are moving away from the gradual release model, I do, we do, you do, as the standard form of instruction, and moving toward a model that leverages student thinking and assets. It is critical for all learners to engage in sense-making, discuss their ideas with their peers, and make connections before and while engaging in guided instruction." This vision drives all parts of the math block, but we really wanted to remind you of it before we dive into guided instruction. Guided instruction can somewhat feel like a return to our old way of doing things, because this is a little bit more teacher-centered. As much as we can, though, we want to try to think about how we can make sure that all learners are truly involved as thinkers and doers at all times. This definition of math instruction is found in your virtual handout number 1. That handout should have been linked where you found this screencast. And in virtual handout number 1, there's also a link to our math instructional guide, if that's a helpful resource for you to reference. The book that you see on the right by Peter Liljedahl, called Building Thinking Classrooms in Mathematics, is an incredibly powerful book that is grounded in years and years and years of his research into how to get the most impactful learning for all students. Here are some quotes from the book that we found to be particularly impactful to us. "Thinking is a necessary precursor to learning, and if students are not thinking, they are not learning. It can be helpful to pause at any moment and look out to your class, look at each student, and ask yourself, are they thinking right now? Am I positioning my students as thinkers? Am I giving them things to think about, opportunities to engage in thinking?" Another quote, "Everywhere I went, I saw the same thing. Students not thinking and teachers planning their teaching on the assumption that students either couldn't or wouldn't think. It's helpful to reflect on our teaching to think, are we positioning students as thinkers? Are we giving them opportunities? Or, as he saw in those classrooms, are we not positioning them as thinkers? Are we acting as though they couldn't or wouldn't think?" A final quote, "Mimicking is bad because it displaces thinking. Mimicking happens not alongside, but instead of thinking. Often in guided instruction, we want to model for our students. We want to demonstrate or do a think aloud. And that's okay, but we want to think to ourselves, are we positioning our students as mimickers? Because if we are, if we're saying, do exactly what I do, watch what I do and repeat after me, if we do that too much, too often, too seriously without including them in the process, we're positioning our students as mimickers. We're removing their opportunities to think. So if you go to your virtual handout number 2, you will see these questions here at the bottom. I would encourage you to pause and reflect on them. In your own class, when have you positioned students as thinkers? When have you instead positioned them as mimickers? What was the impact of this on students' engagement and learning? Use those 3 quotes to support your reflection. So there you see in your virtual handout number 2, a place for you to reflect on your own classroom. With those quotes in mind, we're going to turn to a video screencast on guided instruction. When I say guided instruction, what I actually mean is this screencast is going to talk through a lesson from the beginning. It's going to talk through what a lesson could look like from opening routine to formative task, and finally to guided instruction. I'm sure what you really care about is guided instruction. That's what this session is about. But I think that the opening routine and formative task can be really powerful too, because you can see how the teacher would leverage those 2 components to support students with guided instruction. The video will start with some questions for you to think about as you watch. Those questions can be found here in your virtual handout number 3.
As I talk through this lesson, think about how am I using the opening routine and formative tasks to inform and funnel into my guided instruction? How am I planning to involve students during Connect and Explain? And how am I planning to ensure students have the opportunity to apply and practice? This lesson is a 2nd grade lesson. You can see the learning target on the screen. This is day 13, and students have already spent time adding and subtracting numbers within 1,000. In 2nd grade, it is critical that students add and subtract within 1,000 using strategies based on place value, not standard algorithm, which isn't introduced until 4th grade. We start with a counting routine in 2nd grade. This routine supports students to count by ones, tens, and 100s. Being able to count in this way is fundamental for addition and subtraction. Then we move into this number talk. I'll show this on the screen, and I'll ask students to put their fist to their chest and think mentally, what's 199 plus 23? I prompt students to think, and as they have ideas, they can give me a thumbs up. Once 15 to 30 seconds have gone by and I see a lot of thumbs, I'll ask students to turn and talk and share their solution and their strategies. While they're talking, I'm mining the room and selecting students that I want to share out. As they share their ideas, I'm recording their ideas using a number line to show how they thought about this problem. I might wrap this up before moving into the formative task by saying something like, when finding 199 plus 23, some of you added by place value and composing a 10 and a 100. Some of you thought about counting on to get to the next 100 and then added what was left, which makes that much easier since it's easier to add 200 plus 22 versus 199 plus 23. Let's keep thinking about this as we solve our next task. Then I would launch this task. I might ask students before I even show it who like stickers, and then I'd read the task to them. I'd ask them to turn and talk and share the story of the problem, and then I would ask them to solve the problem. I'd make sure that students have base 10 blocks or bead strings and access to those manipulatives in order to support them. And while they're working, I would monitor students by circulating and making decisions about whose work I want to highlight for the debrief. These 3 pieces of work might be the work I choose. The first piece of work on the left is a nice conceptual representation of the numbers and provides access to all of my students, including those who still need base 10 blocks to help them solve the problem. I would ask all students to make sense of this first piece of work by asking questions like, what do these 4 squares represent? Why did this person circle these 10 lines? What do you think the student did? I would then put up the next piece of work and ask questions like, where do these 200s come from? Why did the student add 40 and 90? How did they get the solution of 533? And then I'd ask students to compare these pieces of work by asking questions like, what's the same and what's different? Then I put up the third piece of work. This number line really gets at what I want students to be thinking about today, adding within 1,000, but relying on number sense to make problems more manageable, similar to what we did in the opening routine. I might ask questions like, why did they start with 290 instead of 243? Where is their answer? Where is their add end? I might end this debrief by saying, you all did a great job using different strategies to add within 1,000. We're going to keep thinking about these strategies and use them to continue to add within 1000. Now we move into guided instruction. This is where we co-construct the learning. So I might put this problem up in front of my students and draw a number line and say to my class, what number might I put on the number line? Maybe a student will say 498, and I'll say, great. And how could we make that number a more friendly number to work with? And someone might say, well, if we hop 2, we'll get to 500. Great, that's much easier to manage. Now make sure that we keep track though. We just took that 2, and I would show students that this is the way that I keep track of what I've already used from the addend. Then I might say to students, now what would you like to jump by? And maybe a student says, I'd like to jump by 300. Great, let's jump by 300. Where will we be, class? And I would have students maybe turn and talk or shout out their answer. We'd be at 800. Awesome. Now what would you like to jump by? Maybe a student offers up, let's jump by 85. Okay, why 85 and not 87? And hopefully a student will recognize that we've taken the 2 here from the 87, and now it's actually 85 is left. So we're at 885. Awesome job. Let's do another one together for Connect and Explain. So now I put this one up and I say, oh, this one's different. There was already one jump taken. How did this person make the jump? And someone would say, we added 10. Awesome. Now what would you do to jump? Well, first, how would we keep track that we jumped 10? We'd make sure that we keep track, and this is how. How would we jump again? What would you like to do? Someone says, I'd like to jump by 200. Great, where would we be when we jump by 200? We'd be at 600. Awesome. What would you like to do next? Jump by 14. Why 14 and not 24? Oh, because we already used that 10, so now we only have 14 left. Awesome job. Now I'd have students go on to apply and practice. I'd give them these 2 problems, and students could work alone or with a partner. And while they work, I would monitor them to see how they are doing. If necessary, if students were really struggling, we could all come back together and I could use one of these problems to do another Connect and Explain, or I could pull other problems to have in my back pocket. Once we finish with guided instruction, we would move into inclusive student activities where students would continue to apply their learning of this exact learning target, and I would be pulling small groups to support any students that needed it. This is what guided instruction is all about. The opening routine, the formative task, all work together to create access to that guided instruction where we co-construct together and students get an opportunity to apply and practice. As I talk through this lesson,
On this slide, you see the 3 questions that Jess asked you to think about while you watched her model. And at the bottom, you see 2 more questions in navy blue. Let's focus on those 2 navy blue questions as you now reflect. How was the lesson she described in the video similar and different to a typical lesson in your class? How did the video inspire you to think about the opening routine, formative task, and guided instruction differently? Pause and reflect on those questions, as well as those white questions if it's helpful, in your virtual handout number 3, where the screencast is also linked for your future reference. One thing I really liked about the video was how, when she did guided instruction, she made a point to ask lots of questions. She could have modeled, she could have done a think aloud, but instead she thought to herself, you know what? I bet I can ask questions to pull that knowledge from my students. That's a perfect example of good guided instruction. In the video, she talked about guided instruction as having 2 parts: connect and explain, and apply and practice. Connect and explain is that part where the teacher models or demonstrates, or better yet, co-constructs knowledge with students by asking them questions. The teacher pre-identifies 1 or 2 problems that students can walk through with the teacher together. Hey, we've never added numbers on a number line before. Let's do that together. Where do you think I might start? Okay, what if I start here at 38? Now I need to add 17. How might I add 17? We're asking questions, we're doing those example problems together to construct new knowledge. And if we need to, if students are having trouble answering those questions, we could say, well, you know what I might do? I might start here at 38. And then if I want to add 17, maybe I would do a jump of 10, like this, and show it. I'm doing some modeling. But then I could ask, why do you think I added 10 first? Modeling, asking questions, constructing new knowledge together. That is connect and explain. Then we want to do apply and practice. Apply and practice is where students have an opportunity to try it out on their own or with a partner. Hey, we just added a couple of numbers together on a number line together. Now I'm going to give you a couple of problems that I want you to add on number lines without me. I circulate, I see how they're doing, I offer support, and I decide, do we need to go back and do another problem together, or are they ready to go to ISA? You can cycle between these two components, doing problems together and allowing students to try a problem on their own. This graphic and information is found in your virtual handout, number 4. Let's do 3 questions together to reflect on what we've learned or to extend it as well. True or false? During Connect and Explain, the teacher should explain and model all new content in relation to the learning target. False. Yes, Connect and Explain is where we learn new content related to the learning target, but in an ideal world, it's not the teacher doing all of that thinking. Remember, we don't want to create mimickers. We want students to be active thinkers and doers. So if possible, rather than the teacher doing all of the explaining and modeling, the teacher's asking questions to help students and be involved in the process. Next question, true or false? During apply and practice, students should independently and silently practice several problems aligned to the learning target. False. Although, yes, apply and practice is when students practice problems aligned to the learning target, it doesn't have to be independent or silent. They could work with a partner. And there's no way you have time to do several problems. 1 or 2 good problems during Connect and Explain, 1 or 2 good problems during apply and practice is absolutely enough. Third and final question, true or false? It's okay if not all students have fully mastered the learning target by the end of guided instruction. They will continue to refine their understanding through more practice, centers, and SGI during inclusive student activities. This one's true. If every student had fully mastered by the end of guided instruction, we could end class early. But no, we still have 45 minutes left in class for the teacher to support different students to reach that learning target, for students who are struggling to get more practice, and for students who have mastered it to push beyond. It's absolutely okay if we haven't fully mastered, but it's good if the teacher has a gauge of who has mastered, who is struggling, so they can target their support during ISA. That's an overview of guided instruction. Let's think about how we can use our resources to plan. If you picture one of our pacing guides from the 22-23 school year, you know that we provide lots of tier English learner and special education strategies. Those can be leveraged during guided instruction. We also provide questions that you can ask students. Again, you can leverage those questions during guided instruction. But the resource that you will most leverage during guided instruction is this row right here. If you are a school that uses Envision, you will most likely go to that lesson and pull questions from it. Expressions, same thing. Go to that lesson, pull questions from it. You also could pull questions from Engage or Illustrative, which are freely available online. We don't provide the exact problems that you want to use for guided instruction because we don't know what your students need and because you have different programs. So unlike opening routine, which we give you exactly, formative task, which we give you exactly, we suggest places where you can go to identify 1 or 2 problems for connect and explain, 1 or 2 problems for apply and practice. This pretty much reiterates what I said. Our advice for planning guided instruction is that all you really need to do is identify those problems. You want to try to pre-identify them before class starts. You don't want to just open up the book and randomly select in the moment. What 2 problems will you use for connect and explain? What 2 problems for apply and practice? And if you have a little more time as you plan, really think about what questions you'll ask during connect and explain. Because remember, again, we ideally don't want to model. We want to make it a back and forth. So if I look at the problem that I'm planning to use for connect and explain, I could think to myself, what questions could I ask students that would help them to walk through and uncover their new knowledge? If I'm stuck and I really truly need to model, I could think to myself, how will I model in a way that is succinct and clear for my students? I would encourage you to pause, go to your virtual handout number 5, and use these questions to guide some time planning. This will help you to reflect on your learning from this session as you think about how you're going to plan for an upcoming lesson. What problems will you use for connect and explain? What problems will you use for apply and practice? And what questions will you ask students during connect and explain? Or if you just can't figure out how to ask questions, how will you succinctly explain the content in a way that makes sense to your students? Hopefully you took a couple of moments to plan and to practice. We're going to close now by thinking back to our quotes from earlier. Peter Liljedahl says, thinking is a necessary precursor to learning. If students are not thinking, they are not learning. I would ask you to pause and reflect. How will you ensure that you are providing your students with opportunities to be active thinkers during guided instruction? As you do that reflection, I would especially encourage you to think, if you're planning to model or to demonstrate, explain how to do a problem, how will you make sure that your students are active thinkers? You don't want them to be just tuning out, not really paying attention, mimicking what you're doing. If you're modeling, how will you involve them? Maybe with a think, pair, share. Turn and talk to your neighbor. Explain to them what I just did. Or pause. Why do you think I just did that? Obviously, you'd be a little more specific than what I am with did that. You would point to what I actually did, but really think about how you can ask questions to get students involved. That's part 1 for guided instruction, very high level overview. If you want more concrete strategies, look for guided instruction part 2, where we will read Never Say Anything a Kid Can Say and get some other great questioning techniques. If you have questions about anything related to the math instructional guide or curriculum, you can email any of us directly, or of course, email math@philasd.